Hey guys, and welcome to the 6th lesson in our Introduction to Pandas series. In the last lesson, we learned about the different built-in functions and techniques available in the Pandas library to perform data cleaning and manipulation. These techniques can help us to fix a lot of problems in real-life datasets, such as text formatting, choosing the correct data type, and so on. In this lesson, we will learn about another practical data manipulation technique, which is joining and merging multiple datasets. So let us move to lesson number 7, joining datasets in Pandas. Data professionals sometimes need to combine and manage multiple datasets to do their analysis projects. For example, let's say you are working on a project to analyze the impact of sport games on food and beverage sales. You will typically need different datasets such as game timetables, sport team performance, sport venues, as well as sales figure from different vendors. If you are using Python Pandas library as your main tool to collect these different datasets, it's likely that each dataset is stored as a different data frame. In order to create a large dataset or combine them together, the Pandas library provides different tools that will help you to do this task. In this lesson, we will learn about two main methods or built-in functions that help you to do that. The first method is the Pandas Concat function, which is a simple combination of two or more data frames in a column-wise or row-wise style. These combinations usually have less restriction about the joining condition. The second method is the Pandas merge function, which allows for a complex column-wise combination similar to SQL query joining. So let us first start with the Pandas concat function. To demonstrate how it works, we can create some dummy datasets about popular sport tournaments such as the FIFA World Cup and the Rugby World Cup. Each one of these datasets has different pieces of information, and we will see how we can add them together. So let's start with the FIFA World Cup dataset. And let's also display the dataset. Okay, so we see here the dataset has 3 different columns, which represent the year of the tournament, the winning team, and the host country. And we also need to create the Rugby World Cup tournament dataset. And for this, the Rugby World Cup dataset, we see that it has different pieces of information. It has the same year, the winning team and host country, but also has the venue and the attendance size of the last game. So let's try to combine these two data frames and create one large data frame. Basically, we want to join the winning teams from the FIFA World Cup and the Rugby World Cup and only use these common columns between the two datasets. So let's have a look at the code to do that. We will need to create a new data frame, and we can call it teams using the concat function. Here we notice that we combined the two data frames together. The one on top was the data frame of the FIFA World Cup, and the second one represents the Rugby World Cup teams. We notice there are several issues with this new dataset. First, on the most left side, the new dataset actually combined the original index value from the FIFA World Cup and the Rugby World Cup datasets. The new index is basically just a combination of the two old index values. Therefore, it includes some repeated values. Another thing we also notice is that it is very hard to identify or distinguish which one of these records belong to the FIFA Soccer World Cup and which one belong to the Rugby World Cup. We start to fix these issues by changing some of the parameters in the Concat function. We first try to fix the key issues by highlighting the source of the data frame. So we will be able to know which one of these records belong to the Rugby World Cup or the FIFA World Cup. So let's have a look and see how we can do that. We notice here we actually used the key parameters within the concat function to add another value that can help us to distinguish which record belonged to the FIFA World Cup or the Rugby World Cup dataset. This parameter actually created something called multi-level index values, which is something we will be learning more about in the next lesson. In other scenarios, we may also want to have totally new numerical index values. So another parameter within the concat function is the option that allows us to ignore the original index values and replace them with the totally new values. So let's learn how we can do that. Here we see that the new data frame, DFTeams, actually include a totally new index value with numbers that are between 0 to 11. And these values ignored the old index values. So in these examples, we have learned that the concat function can be used to combine multiple datasets on top of each other when they have the exact or similar column names or structures. But sometimes this may not be the case, and you want to add together some data frames without having the exact or same amount of columns or structures. This is also possible with the concat function. Let's have a look at how the results may look like. We will again do our DFTeams data frame, but this time we will not specify the exact number of columns. We notice here how the original two datasets were added or combined together on top of each other. However, for the original Rugby World Cup data frame, it also included two extra columns, which are the venue and attendance size. We notice these values were not originally available in the FIFA World Cup dataset. That's why it will be added with the missing values, and only the value from the Rugby World Cup dataset will be available. This type of joining tables on top of each other is what is known as the column axis. If you remember, we also learned before that we have the option to assign which axis a pandas function can be applied to. The axis parameter of the concat function can be changed to allow the dataset columns to be added on top or next to each other. So let's have a look and see how this can be implemented. Okay, and you see here how the datasets were added next to each other. The first few columns, such as the year, winner, and host country, belong to the FIFA World Cup dataset, while the last 5 columns, such as year, winner, host country, venue, and attendance size, belong to the Rugby World Cup dataset. So we learned that the Concat function has the flexibility to do different ways of merging datasets, whether on top of each other or next to each other. It also allows us to highlight the original source data frame or not, and whether you want to keep the original index value or replace them with a new value. These were some of the most common use cases of the Pandas Concat function, and you see how it can be very flexible and useful tool. Now moving to the merge function, which is another built-in tool of Pandas library that helps us to join multiple datasets in a similar way to a relational database operation. So people who are already familiar with SQL may find some similarities about how this function works and how the joining operation in SQL can happen. You will notice that there is a focus on the use of key values and how similar values on both datasets can help to decide how to merge the dataset. So as usual, we need to have some dummy datasets to practice with. In this example, we will create 2 datasets, and these datasets have some similar values in their columns called keys, and also have some different columns too. Let's have a look at the code. The cell was run successfully. So let's have a look at our new datasets. We start with the left dataset and the right dataset. Okay. We notice the 2 datasets have different columns, A, B, C, and D, which belong to different data frames. However, there is one common column called keys. This is the same column name in both datasets. And inside that column, there are some similar values in both datasets, such as K0 and K1, as well as some different values, such as K4 and K5, that only available in the left datasets, and K6 that is only available in the right dataset. Similar to SQL operations, the merge function can take some parameters that can simulate the SQL environment. For example, if you have a common column that appears on both data frames, you can specify that column using the on parameter. Also, if there are some columns names but you have similar values appear on both data frames within different names, you can identify that using the left on and right on parameters. The left on will be the first dataset and right on is the second dataset. The parameter indicator is something very similar to what we used before to show us the source of the original data frame. And finally, the parameter how is similar to SQL joining operation, which can be like the inner join, left join, right join, and outer join. Let's have a look at the first example. In this example, we will join the data frames using the parameter default values, which is basically the inner join operation. And we will notice only the values that appear on both datasets are selected. So this is the name of our new dataset. And here we decide the left and right datasets. And we display the datasets. And we notice that only 4 rows were selected. These are the records within the key values K0, K1, K2, and K3, and originally appear on both the left and right datasets. This is essentially how the SQL inner join usually works. We also notice how the indicator parameter gives us the source of the record. That means these 4 records appear on both sides of the joining table. Now let's try to change the how parameter from the default inner join to outer join to see what's the difference, and we can check if we can get all the records in our datasets. Okay, here we see we joined both the common and non-common columns of the records. The records with K0 to K3 appear to be coming from both the original datasets, while K4 and K5 records appear only from the left dataset and doesn't have any values for columns C and D, while K6 appears to be from the right dataset and doesn't have any values for column A and B. Now you can try to practice some of these parameters on your own and see if you can change the indicator from true to false, and other joining options to see how this merge function can work. So these 2 functions, merge and concat, represent some of the most commonly used methods to join datasets in a Pandas library. In the next lesson, we will learn about how to access and aggregate data using Pandas library. So keep watching.